Hi, welcome to Finchley College. This is a new videos we're producing for our engineering surveying courses. We are a leading provider of nationally recognized qualifications in surveying and setting out engineering. This video is an introduction to principles of surveying and the equipment that you need to do surveying on site. We start with overview of surveying. What is the surveying is all about? Surveying is about position. Everything in surveying is about location, where we are, and where everything is. And location is about its coordinates, the easting, northing, and height of every point. Surveying is about points. Every point has a coordinate, east, north, and height. Therefore, we need to have an axis for surveying. We need to understand where our axis is, where is the north direction, where is the east and negative north and plus east and minus east direction. And when we understand the easting and the northing and the coordinate system, then the totalization works. This is a typical totalization. It works based on the coordinate system. And our coordinate system is typically Cartesian coordinates, which is simple easting and northing. And that is the distance from the easting axis and the distance from the northing axis. So surveying is all about position. And we are essentially position engineers or position surveyors. We are not mainly concerned with anything else except position. Position involves measuring distances, measuring angles, and measuring heights. That is the principles of surveying: distance, angle, and height measurement. Distance measurement is measuring horizontal distance, slope distance, and vertical distance. From the vertical distance, we measure heights. From this horizontal and slope distance and the angles, we measure positions. So all you need to know to work as a surveyor is to be able to measure distance, measure angle, and measure height, and it's all done by this totalization. The job of a totalization is that it's fixed on a location where we know its position. We turn it to a particular angle, so it measures the angle itself. We press distance, it measures distance itself, and from that angle and distance and height, it will demonstrate the coordinate of the survey point on the screen. So surveying is very simple. Anybody can do it. It doesn't need a degree qualification. It doesn't need years of university study for that. Universities waste your time because they teach you so many other subjects. Whereas in this course, it's purely setting out surveying and understanding how to be a surveyor and setting out engineer. Importance of setting out. There are two things we do in surveying. We do surveying and we do setting out. What's the difference between surveying and setting out? Surveying is about finding out the position of the points we are observing. So for example, if I turn this instrument towards a wall and press distance, it will show me its position. The position, that is surveying. When we go to the survey program, we press distance or we press measure. The instrument job is to show me its coordinates. That is surveying. You could be doing it in a field, you could be doing it on a building site, you could be anywhere, and you can be doing surveying. So surveying is about calculating the coordinates of objects. So then we go to the importance of setting out. What is the difference between setting out and surveying? Setting out is the opposite of surveying, is to show, if we know the coordinate of a point, we want to know where it is. And then we want to mark it out on the floor. So we input the coordinate of the instrument, the coordinate of the point into the instrument, and the instrument then, it will tell us what bearing or angle to turn and what distance to measure. So the way it works, simply, if I may just get, okay. So the way the survey works is, say the instrument is set up here. We know the point we want to set out is here. The instrument will calculate this angle and will tell you, turn through this angle and measure this distance. For example, 5 meters, and turn the angle of 42 degrees, 10 minutes, 15 seconds. The job of setting out is all about knowing the coordinate you are, easting, northing, height, knowing the coordinate of the point you want to set out is easting, northing, height, And the instrument, from these coordinates, it will calculate what angle you need to turn and what distance you need to measure. That is setting out. Surveying is the opposite. As you turn and point to the point, you can see the screen, on the screen, the instrument can see the angle. When you press distance, it measures the distance. From these two, it will calculate its difference in easting between itself and this point. This is difference in northing, this is difference in easting. It will calculate how far it is to my right or left, how far is it in front or behind me, and from that, it will calculate this coordinate. Once it knows these differences between itself and that point, it will add it to the station coordinate to calculate the observed point coordinate. And that is surveying. Surveying is about finding out coordinates or positions of points, survey points. Setting out is about marking them out, marking points on the ground. That is what the surveying is. We know that setting out is, we know the coordinate, we want to know where it is. Now, the importance of setting out is that we need to be setting out accurately, we must do precisely, and we need to check our words. Accuracy depends on how important is the point you want to set out. Is it you need to be accurate to 1 or 2 millimeters, or do you need to be accurate to 100 millimeters or 500 millimeters? If they want to know roughly where the point is, then accuracy is not critical. If they want to move exactly to 1 mil, then accuracy is very important. How you achieve that accuracy is through precision. Precision is all about precision of the equipment you use, precision in the methods that you use, and the precision in the information you have. The more precise equipment, the more accurate the results will be. The more precise our methods, the more accurate the results will be. For example, you can measure a distance by total station. Total station's job is to measure distances accurately to 1 millimeter. 1 millimeter, that is all accuracy of a distance measurement with the total station. If I was going to use a tape, I wouldn't be able to measure to 1 millimeter. I have to allow for the slope, I have to allow for tension, I have to allow for temperature and pressure, and all those allowances will make the accuracy in distance measurement by tape maybe 3 or 4 millimeters. So the precision, it depends on the equipment you use, how to do your accuracy, how to do accurate setting out. Checking is the next thing. You must check your work, and you really should have a check system built in your processes so that the work you do, the work you hand in to the subcontractor, to the operatives, is accurate and is correct. You need to check your work yourself. You don't want anybody to find your mistakes. We all make mistakes. Mistakes is one of the things that humans do. And the way to avoid that is by checking. You check your equipment, you check your procedure, you check your equipment, the methods, you check your tools, you check your information on the drawing, you check that the work that you've been given is up to date, you look in the latest drawing, and etc., etc. There's a check sheet that you've got to go through in order to do your work. So the importance of setting out is important accurately, precisely, and have a check system that finds errors. Errors always happen. The more accurate, the more experienced that you become, the less errors you make. The checking will be built in your processes, the way you do your work. Therefore, you'll become a good, accurate setting out engineer. There's a high demand for accurate setting out engineers. On the construction, accuracy is 1 to 2 millimeters. 1 to 2 millimeters. That's what they want from you. Highly accurate setting out precisely. Anybody can do setting out, but you must be doing to that accuracy to work. But sometimes they want it to 10 or 20 millimeters. When that happens, for example, they want to mark out a gully on a road, and that doesn't have to be very precise. 50 mil, 100 mil, 300 mil will do. So therefore, but still we follow the same precision equipment and checking system to set it out to the accuracy. If your work is not accurate, then it becomes unreliable. And if he's unreliable, then everybody will say, this guy doesn't know what he's doing, his work is not reliable, and we need to check it. Now, what tools do we use? Tools and instruments for surveying and setting out. They are mainly total stations and GNSS. GNSS is a tool that we use mainly for land surveying. They are ideal for that because it doesn't have to be set up on a tripod. A normal total station will have to be set out on a tripod. And in that case, it's accurate because it's fixed on a point, it's set up exactly on a point, and therefore is more accurate. GNSS is like a mobile total station. It's fixed on a pogo, and as we move about, the GNSS using the satellites, it will work out its position, and once it knows its position, it can survey and set out points. So GNSS is usually used for land surveying. Why? Because land surveying doesn't have to be very precise. When, for example, we're surveying a road, it doesn't matter if the curb lines are 50 mil here or 30 mil there. It doesn't matter. But when we set out a column or a wall for a construction, we need to be more accurate. So the main equipment is total station, and this is a typical total station. This is a Leica TS06 Plus total station. You can use the latest model one, which is the robotic ones. The advantage of the robotic instruments is that you don't have to stand with them. You will have a pogo, you will have a prism, and you will hold it, and then this will turn and it will lock to your prism, and that will save you standing with the equipment. So why do we use robotic total stations? Because it will free the engineer from standing with the equipment and relying on his assistant to hold the pogo and survey and set out and mark the points on the floor. The engineer can now decide where to hold it, when to survey, and what to do and how to name them. He can see what he's doing. It will lock automatically to prism, therefore no need to look into it, and it's quicker and faster. It will save you also on a second person. Second person is not expensive. Therefore, surveying is about saving cost, and therefore in surveying we tend not to use assistants anymore. Now, basic setting out surveying techniques. When you're doing surveying is different with setting out. In surveying, we are trying to find out the location of the objects we're trying to survey. And for that one, we use the same equipment. We use a total station or we use a GNSS. But the surveying method is about a coordinate system. Now, when we use a GNSS, we'll be using national coordinate system. In this country, for example, in UK, we use Ordnance Survey, national grid. The national grid, the origin is in the sea, is in southwest of UK, is about 40-50 miles south of the UK, so that the whole entire UK is in the quadrant 1. What is quadrant 1? This is their axis plus north, minus north, plus east, minus east. This is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. In this quadrant 1, you can see your easting is plus and your northing is plus. Everything has plus and minus easting. In this one, the easting is minus, northing is plus. In this one, the easting is minus, northing is minus. And in the quadrant 4, easting is plus, northing is minus. So we do always our surveying here. We never use these three quadrants in surveying. Surveying, all the coordinates are plus, positive easting and positive northing for surveying. So we can use a GNSS, and GNSS uses a national grid. And in the national grid, say on a typical national grid, if I move this over, on a typical national grid, if say, imagine this is a map of UK, for example, the origin is here in the sea, and the entire UK is in quadrant 1. So any points in here will have positive easting, positive northing. Now you might use that, or you might want to create your own local grid. A local grid, when, for example, my building site is like that, my grid lines are like that, grid line A, grid line B, C, 1, 2, 3. But the north, in this case, the north is this way, but the north is here in the national grid, is this direction. So in local grid, because your building is tilted and is not parallel to the national grid, you might want to create a new local axis like this. You might want to create a new local axis that is parallel to this one, plus north, plus east. This is a new local coordinate system with a new axis parallel to your grid lines, and that one we call local grid. So, surveying techniques is to establish a coordinate system in your grid system. Am I using national grid, GNSS? Am I using a local grid and using a total station? I can still use a total station with the national grid. I can use both systems, it doesn't matter, but GNSS works in a national grid. Now later on, we can show you how to convert a national grid coordinate system to local grid or vice versa. So basic surveying techniques is simple surveying program. You go to surveying program, it could be quick survey or normal survey. You turn the instrument on, you level the instrument, you set it up on a tripod. We go to a program called resection. So we go to a program called resection. The resection program will tell the instrument where is its location. It will calculate this location for the instrument. You are here. And once we know where we are, we can point to any point we want and turn to any point we want, press measure, and it will show us the coordinate of the point we are observing. That is all the surveying is about. Anybody can do that. It doesn't need mathematics because the mathematics is not like this. The instrument does all the maths. You don't need to know the maths. You don't need to know anything really. You just set it up. You go through the resection program. The resection program is sighting to 2 or 3 known points with the known coordinates. We know the coordinates. Measure to them, and the instrument will calculate its position. Then simply sight to various points and press measure, and it will store the coordinates in the memory. And then we download it through a USB into a laptop. Now, what's the role of total station in setting out? As we said before, the role of total station is the key equipment for setting out. This is the key equipment. Why? Because it can set out and survey to 1 or 2 millimeter accuracy. And most of our setting out, we want to be accurate. Surveying, it doesn't matter. It can be 20, 30 mil accurate maybe, it doesn't matter. But total setting out, you want to be very accurate. Now we can use the GNSS. GNSS, we usually get to plus or minus 10 millimeters accuracy. That's the best. That's the best we can achieve, 10 to 20 mil accuracy. But with total station, we can have 1 or 2 millimeter accuracy. So, if you want to be a surveyor, setting out engineer, you need to learn how to use a total station, and you need to learn these programs. There aren't very many programs. There's about usually 5 or 6 programs. That's all you need to learn. You have to be accurate, you have to be precise, and you have to check your work. These are the 3 key principles of surveying. Measuring distance, angle, and height accurately, precisely, and check your work. Total station. How was the total station developed? The original total station was automatic level. This is a typical automatic level. This is set up on a tripod, like this. And it's got a lot of angles in here. So with these angles, you can turn and you can read the angle in the device, and you can measure the distance. You can measure the distance by, when you look through the instrument, you've got this line and you've got 2 short lines. This is what you see when you look through the instrument. When you look at the level, this is what you read for the level, for the height, but these points on the staff, when you subtract this point from this point, measure this distance, multiply by 100, that will give you distance. So if I set up my instrument in here, and if I'm holding staff in here, and if I subtract this reading from this reading, which are these two stadia, they call it stadia lines, and multiply by 100, that will give me this distance. What is a total station? Total station is an equipment that you set up on a known point that only do measuring angle, measuring distance, measuring height. Automatic level does all three. This was original total station. It was manufactured about 300-400 years ago. It didn't look anything like today's, but it looked very different. But today's equipment is the same as what it was 300 years ago. It measures the angle, it measures the distance, and you can set it up on a point with a plumb bob. This was used for a rough setting out 300 years ago. Still used in developing countries where the total station is very expensive to have. They can use automatic level for rough setting out. Why we still need them? If you're doing a level survey of a point, of a field, you need to know where the staff is held. To survey a field, we need to know that. So we need to measure the angle, we need to measure the distance, and from that one we need to be able, so in that case, you will be highlighting where the staff is held. For example, you are set up here, and all these points are here, and from these, as you turn and you measure the angle and distance, and then you can plot these points on a graph or on AutoCAD. So this was original total station, automatic level. Then it will, after the automatic level, they used a theodolite. A theodolite was equipment just like this one, just that it didn't measure distances. Total station measures angle and distance. So originally, with the theodolites, they only measured angle. They didn't measure distance. This one didn't exist. So they measured angle only. And from the angle, we can measure height as well. Vertical angle, we could measure height. So we measured these two, but we couldn't measure distances. So we need to use mathematics to calculate distances, or we needed to use a tape. Theodolite is not very used very often these days. It's for precision angle measurement. It's used for monitoring, movement monitoring measure. So then the development came that they put a device on top that the theodolite could measure distances, and a total station was born. Total station today measures angle, distance, height to very, very accurately, to very few seconds in angle and 1 or 2 millimeters in distance. So that's the key equipment for setting out. Now, application of setting out in construction. What do we use it for? We can use it for setting out construction elements like foundations, piles, walls, columns, groundwork, ceilings, lights, pipes, anything that goes into construction. It has a position. You get that position from the drawing, and then you go set it out. After you've set it out, you want to go survey, as-built survey, to check it's in the right place. So we do setting out and we do surveying all the time. We usually set out first and we do as-built survey, or we do survey if it's already been set up. So application of setting out in construction is wide applications. You can use it in any field, in the construction of residential properties, in the office blocks, in roads, in bridges, in tunnels, in high-rise buildings, in any field. Anywhere there's a construction, you will be using total station. So once you've learned the total station, you can really work in any field. It is all about position, it's about coordinates, and it's about measuring angle and distance. That's all there is to it. It's very simple equipment to learn and to use. Setting out best practice. What is the best practice? Now, the best practice is that to make sure the equipment is working fine and is calibrated and is working accurately, and you need to learn to check the instrument for calibration. It usually goes once a year for calibration, but you should be able to check it yourself. That is measuring the angles. The newer total stations, they've got calibration program, so you can do that calibration check yourself. Then there are programs on board. The key programs, as we said before, is a resection. You need to do resection to see where you are. After that, you go to stakeout program. Stakeout program. Then you go to reference line program. Reference line or reference arc. And that is all there is. You only have 3 programs for setting out. The stakeout, you will be setting out individual points. You have got a coordinate for the point. You go to upload it in the memory. You select it from memory. And the instrument will tell you what angle to turn and what distance you need to measure. Then you turn the total station to the angle shown on the screen. It says turn me to the right or turn me to the left. When you turn it, the difference between where you are now and where you should be, as it gets, when it's less than 0, that means you're pointing in the right direction. So all you're looking for is the difference in angle between current direction and the actual direction to be 0. Then you'll be pointing in the right direction. When direction is 0, the difference between where you are and when you should be 0, you're pointing in the right direction. The instrument, say for example, is calculated the distance is 5 meters, and then you press distance. If you're too far away, it says come down. If you're too short, it says go back. And you move it towards you or away from you. When the difference in distance between what you're measuring and what you should be measuring is 0, that means you're measuring the correct point. Therefore, any unskilled person can be doing setting out. All you have to do, select the point you want to set out from memory, turn it until the difference in angle is 0, press distance, tell your assistant to come away from you towards you until the difference distance is 0, and that's the point. So you get that by a bit of practice. More practice you do, the more accurate and quicker you get, and more accurate. Accuracy is the key. You've got to be right to the accuracy that the client wants. Reference line program is set up based on a line. Instead of having a coordinate for a point, you can be setting out, for example, I have this line and I want to set out a point X amount from this line and Y amount of the line. So this will be your line and this will be your offset. So if I define this as my first point and this point is my second point, then I'm trying to set out this point. The offset is that dimension and the line is that dimension. So the reference line is setting out in base to a line. To define the line, you need to have 2 points, first and second. You define the first and second, then you tell the instrument, I want to go 3 meters along the line and 1 meter off the line. It will calculate this position and then it will tell me, turn this amount and measure this distance. It goes back to the stakeout program. You could be setting out arc. For example, I want to set out an arc. In this case, the arc usually has a center point, it has a start point, and it has an end point. Or it may be a full circle. In that case, for a full circle, you define a center and a start. And in that case, that will be a full circle. If you have a start and end, then it's not a full circle anymore, it's simply a segment of an arc. So you define it by giving a coordinate for the center, coordinate for the start. Now the instrument knows where the circle is, and then you can set out points at regular intervals, say, along the arc, or you can set out any offset. You can set out 1 meter offset or 2 meter offset, and so you can set out points along the arc, inside or outside the arc, at a regular interval, and you'll be setting out arc. That's all you're doing all day long. You're either setting out a specific point, you're setting out in reference to a line, or setting out in reference to an arc. What is the arc for? You can, if a building has got a balcony, curved balcony, you'll be using a reference arc. If you're setting out a road and there is a curve in the road, you'll be setting out arc. If you're setting out a wall, for example, or you're setting out a foundation in relation to a wall, you can use reference line. You only have 3 programs for setting out: point, line, arc, and also plane. A fourth one is the plane. I should add the fourth. The plane is to setting out slopes. For example, I'm setting out this plane. In this plane, I have the first point, I have the second point, I have the third point. 1, 2, 3. You define 3 points of a plane, and then you can set out this plane. Could be horizontal, it could be sloped, it could be vertical, it could be flat. It's a plane. Plane could be in any orientation. So very rarely you will be using plane. You will only use this when you're doing ramps, or you'll be using for the staircase. That is when using plane. Otherwise, majority of setting out is simply a stakeout and reference line. Today's engineers will use reference line majority of the time for setting out. So the best practice is work accurately, work precisely, and check your work. Use the total station for setting out. Understand your setting is total station, how it works. One is simple, how it works. You level it, turn it on, and it works. Make sure it's working correctly. Make sure it's measuring accurately. Check the instrument for angle and distance errors, and you're off. Safety. Safety is most important. Usually we put it at the top, but now we put it at the end. Safety is about risk assessment. Everything you do in surveying, setting out, you must make sure, especially on a construction site, it's a dangerous environment. You do not want to get hurt, and you don't want to get your assistant hurt. You don't want to send your assistant somewhere down there doing some work, and he falls into a hole. Or there's some work overhead, and something drops on his head. So the safety of yourself and your assistant is paramount. Then you need to look at the safety of the others. This instrument, it has a laser light. So you can see it's got a laser light, and you can set out by turning this. You can see where you're looking and what you're setting out. This laser light, it shouldn't be pointing in anybody's face or eyes. So when you're not using it, you simply turn the light off. When you're using it, turn the light on. That is a safety risk assessment. You must not be pointing the laser into anybody's eyes. Safety of yourself. Am I safe to set up here? Is there any hole nearby that I may fall? If there is slip and trip hazard that I may fall? Is there anybody working overhead that I shouldn't be? So every time you want to set up your instrument, you say, am I safe to set up here? Is anybody working overhead? Is there any hole nearby? Is there too much clutter or may fall over? Is there a risk of, for example, dust, noise, anything else like sparks, somebody is welding nearby, you shouldn't be set up there, you shouldn't be looking at it. Do I have my PPE on? PPE is personal protection equipment. 3-point PPE is gloves, hat, hard hat, vest, and boots is a 3 minimum. Then you might need gloves and you may need goggles. So 5-point PPE is vest, hard hat, boots, gloves, and goggles. That's what the majority of the building sites require you to have it with you. Risk assessment is all about, am I safe to be here? Is it safe for me to send my assistant to work in there? And once you do a risk assessment, you think you're safe to set up, you set up your equipment. Is my equipment safe if I leave it unattended? And that's what we need to do. This was an introduction to setting out and surveying. What we do as a surveyor is simply surveying is about finding out location of points. Setting out is when we have coordinates, how to mark it on the ground. We can mark it using a pin, we can mark it using a pencil marker, or we can use it, a Tipex sometimes they use, or we can use it a fine pencil. Anyway, we mark it so that it stays there for the duration of use. And that's all you do all day long. You get the information from the drawing, you get the coordinates from drawing, you upload it by USB, the coordinates into the instrument, and you go and set up somewhere safe and start setting out. I hope you've gained more information about what is the surveying and what is the setting out and what we're teaching here. This was just overview of what we teach. We also teach you more details of how to use the total station. We go into programs. We use a robotic total station as well as a normal total station. The reason we teach you normal total station is because if you go to a building site and they give you this, you can't say, I only know the latest model and I can't use a normal two-man model. You will also need to learn the robotic total station because they're one-man equipment. They want to save money on a system. They want you to know how it works. You need to learn how to use an automatic level. You need to learn how to use a digital level. The digital level, the advantage digital level is more precise level. Again, it has angles and it has distance, automatically measures distance and the angle. The other equipment you will have a laser level. The laser level is commonly used on building sites. It's for operatives to use for digging, excavating ground to a given level or to do a basic surveying. So generally, what you will learn, we also learn GPS. I haven't got a GPS here today with me, but what you will learn, how to use automatic level, laser level, digital level, total station, robotic total station, and the GPS. Learn them all properly, accurately, fluently, competently. Thank you very much.